another one of the giant lessons here in Chapter 3, and that's graphing polynomial functions. We'll be doing a lot of graphing here until the end. So learning target 8, just graphing regular polynomials, and then learning target number 9, using all of that information to solve some polynomial applications, so doing some problem solving. Here to begin with, we got some hopefully quick vocabulary. The dominating term is just essentially the degree. And so like if I had something like y equals 2x to the 4th plus 3x squared plus 1, okay, the dominating term would be this one right here. This is actually what's going to tell me the most about what the function looks like when I graph it. And specifically, it's the degree right here that tells me the most. So this is all to lead to this. So if I have y equals x to the odd, and this is the dominating term, okay, or the degree, okay, if I have x to the odd, you know, something like x to the 3rd, or x to the 5th, or x to the 7th, okay, well, all of these are going to essentially be that snake type deal. And so x to the 3rd, you know, might look something like this. And well, all of the functions that are odd for the degree are going to look a lot like this, except the bigger the number I get, the kind of the flatter it's going to be in the middle, and the steeper it's going to be at the ends, or with the end behavior. So it'll be steeper and then flatter in the middle, and so forth as these numbers get bigger. But the end behavior, which is a term you'll see a lot in this lesson, is going to be the same for all of them. As x gets smaller, the graph is going to go down, and as x gets bigger, the graph is going to go up. So you can see they're all going to go up here, and they're all going to go down that way. When you have x to the even, like x squared, or x to the 4th, or x to the 6th, okay, anything that's got a dominating term where the exponent is even, these are all going to play out like a parabola. Okay, you guys all know that x squared gives us this nice parabola. Okay, but if I do x to the 4th, very similar to how I had odd exponents, it's going to get flatter at the bottom, and it's going to be steeper at the end behavior. So it'll still kind of look like the U. It'll just be flatter here, and it'll be steeper here. And again, the end behavior is that as x gets smaller, it's still going to head up, and as x gets bigger, it's still going to go up. All right, so turning points. So if you have a polynomial of degree n, okay, so anything 4, 3, 2, 5, 7, okay, there are at most n minus 1 turning points. So if you take a look at some of these, well, this right here is a turning point. It goes from going down to up. Here is essentially a turning point. Okay, and so you can see that if I have something x squared, the most I could have is 1 turning point. 2 minus 1 is 1. But even then, let's say we had x to the 3rd. You know, not all x cubed functions perfectly look like that snake. Sometimes you'll get something that looks like this. It'll kind of have an extra dippy-doo in there. And you can see that you would wind up having 2 turning points, even though it was x cubed. Multiplicity, sometimes you can have what are known as double roots. So a lot of times you'll see something that looks like this, in which case it's kind of like it touches this in 2 spots. Something like x plus 1 squared. and then maybe like an x minus 3 or whatever it is. But you can see that you have kind of these double roots. X equals -1. Well, it's like x equals -1 twice, and that's a deal with multiplicity. All right, so let's move on. Some multiple choice. So which function goes with which? We haven't even started graphing yet, but let's just be able to identify what would go with what. I look at the dominating term here, and I see that I've got positive x to the fourth, which means it's gonna, the end behavior is gonna be similar. It's gonna be concave up since it's positive. So here I've got end behavior where they both go up. It kind of resembles that U shape. I should expect it not to look like a perfect U because I have a whole bunch of other junk going on here. But this would be the first one. So if we called this one A, that would match with this one right here. Let's see, negative x to the 6th. So again, I have an even dominating term, which means it's going to be that U type of shape, but I also know that it's going to be flipped upside down, reflected, because I've got this negative sign. So if this one is B, well, then this one right here would have to match that. All right, moving on, x cubed, so a dominating odd term, that's going to be the snake, and because it's positive, it is going to look a lot like the x cubed snake. I know it's not going to be exactly like that because I got a bunch of other stuff, but I think that would have to be this one right here. And then finally, x to the 7th. Again, the dominating term has odd, so it's going to be kind of that snake type thing. But I also know it's going to be essentially the opposite or reflected of the original snake, like this one. So it's going to start up and go down. All right, so hopefully that helps you just kind of be able to identify what it should look like, and that's going to help later on when we're actually graphing them. Now, as we merge into actually graphing, what is enough information to graph by hand? Because obviously if we're graphing, it's not going to be perfect like a calculator was doing it, so how close do we have to get? Well, there's essentially a 3-step process to be able to just say that you've covered enough of your bases that it's close enough. Step number 1, you're going to want to find your x-intercepts. Okay. How do we find the x-intercepts? Well, that was what we basically just did in lesson 3. Okay, you're going to find all of the factors using the rational roots theorem and all that, and solve. Okay, and that is going to give you all of your x-intercepts, and those will be very key pieces as we do this. Step number 2, find your y-intercept. Okay, find the y value equals what when x equals 0. Usually going to be your constant. Okay, and so that's one piece that will also help us accurately graph. And then at this point, your final step is use what we just learned about end behavior. And kind of what we know already about it. We know that at most you can have a certain number of turning points and all that. All right, the intermediate value theorem, I think we'll probably save that for another day. I think we've got enough to work with right now. All right, so just some basic ones to work with before we get into the real ones. So here we have x to the 5th minus 2. Well, we can use all of our shifting knowledge to help us with this. It means I know my key point, the turning point, essentially, is going to be right here at -2. And then I have x to the 5th. Well, if I had 1 to the 5th is 1. And so I go over 1, up 1. -1 to the 5th would be -1. So it'd be kind of down here like this. Of course, I know it's not a linear function. I know it's going to be kind of the snake thing. And I know that it's going to be kind of flatter at the middle. And it's going to be steep towards the end. And that's about how I'd finish it off. Okay, and so that's good enough for graphing that by hand. All right, let's try another one. So here I've got x plus 1 to the 6th. So because it's to the 6th, I know it's going to be relatively flat like that. And because it's plus 1, I know it's going to shift to the left 1. So I've got there. That's going to be my, again, my turning point. 1 to the 6th is 1. And negative 1 to the 6th is positive 1. Again, but as I go through this, I know that it's going to be real steep. Going through here, and then it's going to be real flat going through here. And so that's about enough to graph that one. All right, let's try the last one. So I've got a lot of shifting going on. I know I'm going to go 1 to the right and 3 up. So 1 to the right and 3 up. That's going to be my turning point. This is going to be one of the snake ones. It's really just going to be the snake because this is x cubed. It's not going to be as flat in the middle. But I do know that this negative 2 is going to flip it upside down and kind of make it more narrow. So 1 squared, or 1 cubed would be 1, and 1 times negative 2 would be negative 2, so I'm going to go down here. And then negative 1 cubed would be negative 1, but negative 1 times negative 2 would be positive 2. So I've got this one here, and again, I can just kind of connect my dots, but I am going to have to know kind of what it's supposed to look like. And so there we go. All right, so those are rough graphs that hopefully are good enough. You can always check your answer with your calculator or Desmos and ensure that you got the right thing. All right, so here it is. Here we've got an actual polynomial that we need to graph by hand. So I told you there's going to be kind of a three-step process, so to speak. First step, find all of your x-intercepts. And so that's going to just build on what we did in the previous lesson. We're going to do the p over q deal. So all of the factors of the constant. So I've got negative, positive, negative, and then I got 1, 2, 3, and 6. And then for the q, I've got positive, negative, 1, and 2. And so how does this play out for all of my possible solutions? Well, I could just go ahead and just take each one of these, divide them by 1, and divide them by 2. So I got positive, negative, then I've got 1 divided by 1 is 1. 1 divided by 2 is 1/2. Then 2 divided by 1 is 2. 2 divided by 2 is 1. I already got that, so I won't write it again. I got 3 divided by 1, which is 3. 3 divided by 2, don't have that one, so I'll write that one down. And then 6 divided by 1 is 6. 6 divided by 2 is 3. I already got that one. All right, so there you go. I have 2, 4, 6, 8, 10, 12 possibilities for my answers. You can go ahead and just graph it on your calculator to get that one. I think for this one, I probably would give you one of the solutions to begin with. And so I'll just tell you right now that 1, positive 1, is one of my solutions. Okay, and so we'll graph this out, or we'll do the synthetic division. So 2, 5, negative 1, and negative 6 go here. So hopefully you're getting pretty good at the synthetic division. We drop this down. 1 times 2 is 2. 7, 1 times 7 is 7. So I got negative 6. So, positive 6. 1 times 6 is 6. And so, of course, we get 0 here because I told you it was a solution. So at this point, we would say that 1 is a solution. So that means x equals 1 is one of my x-intercepts. At this point, what I would have left for factors, I'd have x minus 1, but then I would have 2x squared plus 7x plus 6. Okay? And, well, this can be factored as well. So I got x minus 1. Now that I got it down to a quadratic, these are pretty simple to factor. We'll say 2x and x, both going to be positive. So I got 3 and 2. And this would be what gives me the others. So when I want to find the x-intercepts, it's like 0, so I'm using the 0 product property. And that leaves me with negative 3 halves and negative 2. as my other solutions. And you can see that negative 3/2 is one, and negative 2 is also one of my possibilities up here. So let's plot that out. Negative 3/2 would be like negative 1.5. And then negative 2 would be right here. All right, that's a little close, but all right, other key pieces of information. Step number 2 would be the y-intercept. And well, the y-intercept is just f of 0. When I plug in 0, I wind up with just that, my constant, so negative 6. Negative 6 is my y-intercept. So I've got the x-intercepts, I've got the y-intercepts. And now I take a look at my dominating term to get my end behavior. And so I look at this and I think to myself, okay, well, I know that it's x cubed. So I know it's going to kind of be going down this way. It's going to be going up this way. I also know that it can have at most 2 turning points. So at this point, I kind of wing it. I could pick some values to pick for x to just give myself a little bit more accuracy. Maybe pick like negative 3, see what that equals. Okay, but I think for most things right now, it's going to be okay if I just kind of go up here. And I got a pretty good idea it's going to start coming back down here. And then it's going to hit this point and then come back up. And hit this one on its way up. And there I have graphed my formula, or my polynomial. Okay, and so again, I could be as accurate as I want if I pick a few more points. I might want to pick a point in between negative 3/2 and 3 just to make sure that it kind of ends up right here. I might want to pick a point here, maybe pick a point here. But in the end, that's what we got. All right, now the final thing here is a little problem solving. And this, you're going to use your graphing calculator. It's quite a bit of steps here going through it. So I'll just kind of help you out. What you're going to be doing is you're going to be going on your calculator and you're going to graph all of these points. Okay, and so here's what you would do, just kind of the steps on your calculator. You go to Stat, which is kind of top middle, and then go to Edit. And then at this point, you'll have some columns, and you just fill in your data. Okay, so I usually just make this L1 and this L2. Make sure that you're using 0 for 1995, so that would make this 3, this 5, this 9, this, let's see, add 4 to that, that would be 13, and so this would be 16, okay? So you plug these numbers into L1 and L2, and then what you're going to want to do, if you want to plot these, you do your second feature, usually the yellow button, and then you go to Calc, or sorry, Stat Plot, which is right above your y equals key, and then you just turn it on. Okay, and then it probably won't fit the window. I mean, 39,000, that doesn't fit on the standard window. So at this point, fix your window so that you can actually see things. All right, your next step, and this is what kind of the key thing is, because you want to write a function that best fits this data so you can use it to predict things. And so you're going to go back to Stat, and then you're going to go to Calc, which is the next one over. And then once you're there, you're going to have a variety of best fit graphs, okay? And you're going to want to do essentially each one to see which one best fits it. You've got the quadratic, which will best fit it with a parabola. You would also have a cubic, which would best fit it with something to the third, and then quartic, which would be something with to the fourth. And so you would do all of these things, and you could graph them out and you could see which one was the best. But each of these, when you do this and press enter, they're going to give you a degree of accuracy. R squared is kind of what that would look like. And usually it's a pretty high number, but the one in this case, if you do all three of these, this one, the closer to 1 we get, the more accurate it's going to be. The quadratic was 0.997. The cubic was 0.998, and the quartic was 0.999. I actually had a few nines after that. And so the quartic was the one that best fit this data, and so we would use that function to predict future values. So that's kind of the process there that would help you with problem solving. All right, that's what you got. Enjoy.